Okay, on the screen you can see a 2D list. Now this means it's lists within a list, so therefore it's two-dimensional. Now these are incredibly useful for anything that you might use as like a grid-based system. Is a very easy way of using it as an analogy. There are many other uses as well, but if you imagine you were recreating something like the game of tic-tac-toe or noughts and crosses, you might want a 3x3 grid, which is kind of what I've created here. So we've got a list in position 0 of this list, which contains the numbers 1, 2 and 3. And then within the next section, I've got another list, 4, 5 and 6. And within the next section, I've got 7, 8, 9. So for example, if I did for item in my 2D list, print item, when I run it, just move this over, you can see it's done a little 3x3 grid effectively. So we've got position 1 in the top left and 9 in the bottom right. It's because my loop actually runs 3 times, because in my 2D list I've got 3 items. I've got that as one item, because look, we've got the square brackets, then we've got a comma on the other side, so that's one whole item. That's the second item, and that's the third. So that's why it looks like a 3x3 grid, because it's printed that one item at the start, then that, and then that. So this is a 2D list. Now it's worth knowing that this I've called the video a 2D data structures, because you can have, it's not always related to lists. You can have other data structures within data structures. So I could have dictionaries within a list. Okay, I could have lists inside a tuple, but then that kind of defeats the object of one being immutable and one not, but you get the idea. Typically you would use lists for a lot of these, but it's where you put one data structure inside another, and I need to explain how you access and change data, because it's slightly different. Because obviously when I'm looping through, an item is now a whole of the list. So all I need to do is, if for example I only wanted to print out the first item from each one, I could just loop through like this, and I could at the end of here put square brackets. Remember, this is a list in itself, and put the position 0. So that's going to get the first list, which is that, and it's going to output position 0, which is that. Then it will move on to the next list, and it'll output position 0, which is 4, and then it will go on to the next one and output position 0, which is 7. So when I run it, you can see it says 147. So you can loop through like this. Now realistically, the most common thing you're going to want to do if you're programming using a 2D list is loop through the entire thing, one item at a time, which I'll show you how to do, and also the normal add, remove, delete, that sort of thing. So let me go through that. So if for example mine is called my 2D list, I'm just going to print it out at the bottom so we can see it as we change things. So my 2D list. So if we did dot append here, like we do with normal lists, and I put the number 10 as a string, when I run it, so I just missed the end off append. When I run it, you can see it's actually added that as a 4th item. So item 1's a list, 2's a list, 3's a list, and then 4. It's just an item on its own. It's not even inside. It's inside the outer list, but it's not inside its own inner list. So I could append a list if I wanted to add another row, for example. So I could do comma 11, comma 12. And then when we run it, you can see it's got now a 4th row. So when you do a dot append, that's adding it to the end of the main list, these outer brackets here. If I wanted to add something to row 1, what I would need to do is, let's just add the number 10 to the end of row 1. What I need to do is do my list in square bracket 0 dot append. Because my list square bracket 0 is this first list here, because it's in position 0. So then when I do dot append, this 10 is going to go on to here on the end of that list. So you can see, look, it says 1, 2, 3, 10. Oh, it's because I've got it in square brackets. So it's added, that's all going into a 3-dimensional list. So there we go, 1, 2, 3, 10, 4, 5, 6, 7, 8, 9. So you've got to be careful where you add it. Now, you might spot that if I'm saying my 2D list square bracket 0 is a list in itself, anything you could do with a normal list, you can just do after these brackets here. So like dot append would work, everything else, dot count, etc. You can also do further indexing. So I've now got, because it's a 2D list, 2 levels of indexing. So I could do 2, for example. So that's saying go to position 0 of the outer list here, then go to position 2 of whatever's at position 0. So if a list is at position 0, then to position 2 would be 0, 1, 2. So it would be that item there. So when I run that, I need to print this to show you working. If I print that out, it's going to print out the number 3. Okay, you can use this, so hopefully if I do 2, 1, you'll know that that would print out the number 8, because in position 2 of the main list, so position 0, position 1 and position 2, remember I'm looking at these commas, then within position 2 I'm then going to position 1, which is the number 8, because that's 0, that's 1, that's 2. So when I run it, it's the number 8. So the other thing you might want to do is you might want to loop through the entire grid. So imagine you were making, I don't know, the game Battleships, and you want to loop through and count how many spaces are left or something like that. I'm just coming up with this off the top of my head, but you might want to treat this as, and I'm going to print out again to show you. So I'm going to say for I in my 2D list, print I, just to show you as a reference point while I'm doing the rest. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to print those out in order. So I need to start by accessing position 0, then looping through it, then go to position 1, loop through that, then go position 2 and loop through that. So the way you do this is with 2 loops. So I could say for row, which is effectively what each section is, for row in my 2D list, and then I want to then do I want to loop through the row. So then for item in row, print item. So that's, let me delete it and run it again. So that's, yeah, it's because I've got that there, sorry. So that's printing out each item one at a time. And if we go through Y, this loop here is looping through each row. So on the first pass, it's that, because it's each item one at a time on the outer loop. So the outer list, which are these brackets here, look, the items are that list, then that list, then that list. So this loop is going through one at a time. So on the first pass of this loop, when I press run, row is equal to that. So when row's that, before I change to it becoming anything else, I'm inside the loop, remember, with our spacing. So then I'm looping through that. So I'm then saying, right, for each item in that, print the item out. So it will go 1, 2, 3, and it's done. So then that loop will finish, and then it will go back up here to here again, and it looks at the next thing that's going to be row, which is that there. And then it will loop through that and print out each item, and then it will go there, and then it will loop through that and print out each item. So that's 2D lists. Now you're going to use 2D lists and 2D data structures quite a lot in the more complicated tasks that you might find, especially like early days. It would be things like making games, battleships, tic-tac-toe, that sort of thing. And you might find this is a really nice, easy way of doing it. Or easy might be a stretch, but it's a nice way of doing it.